Recording in progress.
All right, so welcome back, everybody. Today we're going to do 2.2 in statistics. This is on bar graphs versus histograms. So I thought maybe we would start off by showing you some examples of each, and we can discuss what they have in common and what they don't, what's different between them. So I pulled up, this is a superhero survey, and I got a couple bar graphs up right now. I started with bar graphs. This is a simple, this one was on the alignment of superheroes, whether they're bad guys, good guys, or neutrals. I think the dash is no response. And then here I did eye color. And let's take a look at what eye color gives us. We have a giant bit of information. Amber, black, blue, blue-white, brown, which was probably brown but misspelled. Hazel, red, silver, you know, a range of colors. I'm not sure what this one is. This is yellow but without irises. This is yellow-red. Okay, so this is kind of an example of what bar graphs look like. Let me bring that back up. There we go. I wanted it smaller. We could also look at these are with words on the bottom. Let's see if we've got a bar plot we can do with numbers. We can do height. Height's going to be in numbers. And look what it says. Whoa, lots of unique numeric values for height. Want to turn on binning for this procedure. So I'm going to turn it on and just and show you what happens and discuss what's going on. So what it's done is okay, there was heights between 0 and 1,000 centimeters. 1,000 centimeters is a kilometer. No, it isn't. 100 centimeters is a meter. So 10 meters tall, 30 feet tall. One of the superheroes is in 30 feet, and the rest are in a smaller range, 1 to 2 meters, which would be standard. So we can do numbers and words and sort. When there's a lot of unique responses, I'm going to do this again without binning and show you what happens. We're going to do height again, and I'm not going to bin this time. And look what happens. Every single possible answer is listed with its frequency. So 26 people were 165 centimeters. That seems like a lot. 59 superheroes were exactly 183 centimeters. This sounds a little fishy to me too. That's pretty specific. 1.83 meters tall. But notice we got a lot of bars here. This is not helpful. You would look at this and go, not helpful. But when I turn on binning, it chose 0 to 200 as the bins, which also seems like maybe that's not very helpful because like they're all in one stack and there's very few in the other stacks. Do we have any options on what we can do to edit these? Hey, Emmanuel. There's no option here to set binning in this. But we will look at options in other scenarios. And then this is the same thing for height, but notice it's looks a little bit different. Here the bars were separated by space. Here the bars are not separated by space. It looks like each bar here is 100, 0 to 100, 100 to 200, 200 to 300. This one right here is a histogram. So I'm going to go, I'm going to bring up, I'm going to close these and talk about the differences real quick and show you how to access them and do stuff like that. And then we'll do a problem from the book, from your homework set. So what kind of things do they have in common? Well, they both have rectangles, right? Rectangles are boxes or bars. And both of these did frequency. It counted up how many in each thing. We could also do relative frequency. That's kind of the end of what they have in common. Let's take a look at what bar graphs have that are unique to them and what histograms have that's unique to them. We saw on the bar graph, first off, we noticed that the bars didn't touch. And on the histogram, the bars did touch. We noticed that we could do categorical data like hair color, eye color, or quantitative data like height in centimeters was one of them. Quantitative. On the histogram, it's only quantitative. Okay. Since histograms just stick with numbers and they do numbers uniquely, we can only have one data set or data type for each graph. But on the bar graph, I could put like male and female side by side up. So we could have more than one category on the same screen, same graph. Let's say group bar on each graph. We've all seen bar graphs where the bars can be horizontal. And we just saw vertical. So bars can be vertical or horizontal. And that's up and down or left and right. Up and down, and the bar horizontal is left and right. Over here on the histogram, bars have to be vertical only. And then something else that is different between them, since bars can have categories and not numbers, these can be in any order. Bars can be in any order. But on a histogram, they have to be sequential along the x-axis. Sequential means in order. The x-axis. When you're done writing that, we'll go and look at some more in there. Let's see. Yeah, I see a chat message. Yes, in regards to value. And I'll show you in a second what that means. We'll be a little more specific. Does anyone need this up longer, or can I switch to the other stuff? Okay, let me know if you need that back. I'm going to come over here and bring back some of those graphs real quick. I'll bring back the bar plot and the histogram. Okay, so the bar plot's on the left, the histogram's on the right. In order, notice that it goes 0 to 200, 400, 600, 800, 1,000. That's in order. It has to stay in order. The ones over here, they are in order right now, but I can choose to change the order to something different. I can do order, right now it's value ascending. I can do count ascending. And I'll click on OK. And now notice I've got 600 to 800 first, then 800 to 1,000, then 200 to 400, then 0 to 200. Bar plots, bar graphs are doing categories. They're treating the numbers as categories here. And so generally it does in order would be alphabetical when it's letters, when it's words. When it's numbers, it goes numerically, but we can change the order to be based on count. I don't have this option over here in histograms. I can change to frequency or relative frequency, but that's about it. So how do we get to both of these? I did graph, bar plot, and we did with data because we have the data. And that's usually what you'll end up doing. You'll have data and you're doing a bar plot and a histogram. So I'll write that on the page in a second. You can also get to... No, you can't. Yeah, that's the... Let's see. Am I missing something? Yeah. So bar plot and histogram. So... And that's under graphs. I'm going to show you some more stuff on this. Let's start with some fresh graphs. When I choose bar plot, notice I have a variety of columns I can choose from. I can do name, gender, eye color, race, hair color, height, publisher, skin color, alignment, weight. That is quite literally every single column. I can choose all of them, any of them. I can choose more than one. I can tell it to do by relative frequency. Ascending works. We'll do value above bar. You have the option of displaying more than one graph on a page. There are ways to set it up where it does by mailer. Like I said, we could do more than one data type on a bar. I could break this up and group it by gender. Let me group it by gender and do alignment. This is a good one to take a look at. So it says blue is not, it doesn't, it's maybe non-binary is what they were going with. Red is female, male is green. Red is female, green is male. And each category, we've got how many bad guys versus how many good guys are by gender. We don't have this option in the histogram. I see something in chat. Yeah, let me bring the notes back up. Do you need more on the screen than that, Natalie? Let me do this.
No, just that.
Okay. Just holler or say something out loud verbally when you're done.
Okay, that's good.
Okay. So I'm going to move this to the side a little bit. I'm going to do this best. There we go. I'm going to do this right here and put on a new piece of paper and like talk about some of the prompts you have in the bar plot and in the histogram. And it's easier if I have the box up at the time. Let's do it side by side. That'll work. Okay, so bar plot options. In StatCrunch. So any column works, but you have to pick at least one. Otherwise, you're not graphing anything, of course. On the types, you're really only going to use frequency or relative frequency. Oh, what is this? That's a new one. Let me see what it does. That doesn't really say. So you're really going to stick with frequency or relative frequency, like we were talking about. But if you want to group, if you want to do if you want to break down each bar into subcategories, for example, by gender, which is what we just did here, you're going to choose the group by box. And in that box, it's a drop-down menu. And you tell it which row or which column has the subcategories. So that's why I clicked gender earlier. If you group by, you have two options for the grouping options. So if you do this subcategory thing, you have more little sub options that really are not important if you don't have grouping. The grouping options are like this. Split bars will do, side by side categories like this. And the other one should be stack bars. That's where it stacks the boxes on top of each other. And I'll show it in a second. And then separate graph for each group is kind of apparent. You put all it, this was breaking down into males and females when we did this. It puts all the males on one graph, all the females on another graph. Let's look at the stack bars real quick just so you can see it. So that's the difference between the two. Split bars is side by side. Stack bars are on top of each other. The order, then you have the order by options. So the value categories, values ascending is going up and descending is going down. But this is by the name. So that's option 1. Option 2 is by worksheet. And this puts columns in or uses bars. Bars are picked by according to what comes first in the data set. And finally, your other last option is counts. And you can again do ascending, which is up, and descending, which is down. And here, rather than doing it by name, what count means is this is by frequency or relative frequency, something like that. So count ascending means lowest frequency ones first. And descending means highest frequency first. I very rarely do worksheet. The only time I really do worksheet, PyGraph has this also, is when I'm trying to put them in order and it's not matching up with what I see in the homework set. So the homework set will be doing in like worksheet order. And so sometimes getting the graph to look like theirs, I need to click on worksheet. Other than that, these all have their uses. Like value ascending just does it. I'm going to go back to this split bar graph because I like that one better. Its value ascending is going by B, G, and N, the first letter. If I do count ascending, notice the bars are getting taller as I go right to left. This might be handy if you really want to know which ones don't show up that often. They appear on the left. Same thing with descending. Which ones show up the most often? You might really care about those the most. And see these numbers above the boxes? That is an option in the settings. Display value above bar is, I always recommend turning this one on. And check it. The rest is all I'm doing, making how you do the presentation. Like notice right now, it says alignment across the bottom. I could make it say something different than alignment by changing the x-axis, because that's the axis down there. Maybe I'll say superhero alignment. And over here, I might say, since it's frequency I'm doing, I might actually say frequency. And I could give it a title. Superhero alignment by gender. So I was able to edit some of the text on it. When you actually have the thing open, and if you just want to change one setting, you see me keep doing it here. You can click on options and do edit. And it just reopens the box and allows you to, it keeps all the settings you had before. So if you don't want to do relative frequency, like I labeled it frequency, so maybe I should put it on frequency here. And maybe I don't like count descending, I'll do it by worksheet. And worksheet, apparently good came up first, bad came up second, no response came up third, and then neutral came up last. And we'll go over doing like saving a copy. It'll save it in your stack crunch stuff. If you wanted to use it for like in a project, you could do download and give it a name, like what you want to save it as. So those are ways to do that. Well, when project comes up near the end of the semester, the last 6 or 7 weeks, I'll re-go over this graph saving and stuff. Is there any questions about the bar plot?
Can you please move the paper a little to the left?
Like that?
Yes.
All good?
Yes.
Okay. Let's take a look at histograms now. Graph histogram. When I do graph histogram, I don't have every column available. I only have the columns that have numerical data. Okay, so it's only columns with numerical data. Or numbers in it. I still have the same thing that's like, I'll do the height here. I can still group by the same thing. So some things remain the same. We need to pick a column. We can still group by gender or whatnot. I'm going to leave that off for now. I don't know that it helps. We still have frequency and relative frequency. Let me... I keep picking between the windows. I should just make this window a little bit smaller. There we go. And then notice it says we got a new box. We got bins. And we have the options are start at and width are optional. Just display options of overlay distribution. You won't use it. I never do, and I use this more than you guys do. Value above bar is still the same. Good stuff. I'll go over the bins in a second. Value above bar is always still a good option. And then we also have the option for the markers. And we can choose mean and median. And we can choose colors for either. Mean is the average amount. We'll be calculating this in chapter 3. The median, like the highways have medians, it's the center. Median means the center amount. So if you put them in order, the number that's in the center. Let me pause there and let you guys write that, and then we'll take a look at it. I've never used dividers, and then we have more labeling and stuff. So the big things that are different are these markers and these bins. If you don't choose anything for bins, the computer is going to pick it for you. So that's good to know. All right. I'm going to actually choose a different project. I'm going to go back to the one I had a second ago. I'm going to go back to my survey. And we're going to load up the data set we've been working on, or people have been answering. Why is that not letting me? Oh, analyze data. There we go. So I'm going to do the graph histogram here with ages. Why? Did somebody put some nonsense answer in these columns? Nope. Let me go back to not an active survey. Let me go back to stored data. This is the same one, but it has less responses and it doesn't have your guys' responses. There we go. Now I can do age. Everybody done with this page over here? I'm going to get out a fresh sheet to talk about this binning, because it comes up. Caprice, this is what you were just asking me about before class started. And we'll actually look at the problem in specific in the class in a second. If you need that back, let me know. So if I don't click it, let's just skim the ages real quick first. I've got the first person that responded was 63. I've got people 19. I got a 17-year-olds. I've got 48. I've got a range of numbers. Ooh, 79. I had a 79-year-old person respond to this. I put this up on Facebook at one point. And so people were adding to it from Facebook. So I've got a wide range of ages here. 65 again, or an age in the 60s. I'm sure I have, 14-year-old responded. So we can see a wide range of ages. So if I let it do it on its own, what does it choose? The easiest way to find out when you can't see all the numbers for each bar across the bottom is put your cursor over one of the bars. And right now, it is saying, example of binning. Right now, it is saying frequency 79. And it says age 15, 20. The left side is a rectangular bracket. The right side is a parentheses bracket. This is mathematics notation. What this means is include numbers as low as 15. And the bracket gives me the include part. With 15. It'll include 15. The parentheses with the 20 right here says include numbers up to 20. But not 20 itself. So the real list of ages here would be 15, 16, 17, 18, and 19. And if anybody used decimals, said 19.5, it would do that. Notice the next column says 20 to 25. So it does the 20 again. And then it says age 20 to 25. Same format. This is doing 20, 21, 22, 23, 24, and all the way up to 24.999, but not 25. This is how StatCrunch does it. It's not desirable, though, and the reason why it requires you to remember what these parentheses mean, and the 20 is listed twice. So you gotta, like, where the hell is 20? Are the 20s in this group? Are the 20s in this group? You have to stop and think about it. So this is an undesirable thing in StatCrunch. When you're doing the homework is not going to want you to put that. The homework will want ages listed like this: 15 to 19, 20 to 24. That way there's no confusion on where the 20 goes. And I'll show you an example in a second. So homework will want this format. These are called bins. Kind of like if you had boxes and you had everybody's age was on a slip of paper and you had boxes and you had them labeled 15 to 19, 20, 24. You get that, or a bin or a box. You look at your survey thing. Oh, this person's 17. I throw this survey into the 15 to 19 box. Oh, this person's 26. I throw it in the 25 to 29 box. Okay. So this was auto binning. The computer chose the values. Now I got a lot of bars here, and maybe I don't like this many bars. This is where the start and width come in. So in our options, StatCrunch options, the start at says, and it doesn't go by the data in your graph. It goes by whatever number you want. I think the lowest person we had was 14, but start at is pick the lowest value that shows lowest value bin on the box. Where does it start? Or bin on the graph. Where does it start? I'm going to show an example. I'm going to put 0 there. Okay. I think it started at 10. Let me click cancel. Let me see where it started already. See, the first bar here only has 10 to 15. So the auto binning started at 10. I'm going to change it to start at 0. And then it currently, the width is what the width asks. How many values do I want in each? If I want to do every 10 years, or another way of saying this is how wide are my groups? Because we've got a 15 to 19, that's it includes 5 years. Subtraction doesn't show that to you, does it, though? 24 minus 20 would show you 4. That really is covering 5 years, 20, 21, 22, 23, and 24. So that can be a little tricky if you're figuring out this is not a width of 4, it's a width of 5. If I tell it 10, now notice my first box right here, it says age 0 to 10, frequency 0. So I can tell it to have boxes that don't appear on the graph. And now each column is exactly 10 wide, 10 to 20, 20 to 30, 30 to 40, 40 to 50. I can keep that width of 10 and make it start at a weird amount. Like what if I said 8? Start at 8 and do a width of 10. Now I've got 8 to 18. Now that might work for some things. It starts with kids or people that are not adults and then keeps going up. Picking your starting value and your width kind of really helps. Notice how much different these graphs are. Let's edit it. What they started at was 10 and a width of 5. This was the default setup. Notice I got a really tall column in the beginning, and there's a lot of short columns. Notice I even have a gap here. There was a 79-year-old, but there's no one between 70 and 74. Or I can change this to just go with start at 10. I think doing 0 to 10 is silly. I could do it by every decade. And now it's got a more like gradual curve going on. And now I don't see that hole for this 70 to 74. There will be problems in the homework. I'll go back to the 5 for a second. Just because there's no frequency here in the homework, if there's a category listed there, you still need to list it and show 0 frequency. So that's important to know. So, like picking what these are kind of matters. I think in this chart, this data set, I have a graph. I do not have GPA. Or not GPA, but number of units. If I had a question here for semester units, if there was a units completed at school, a width of 10 is not good. What would make a good width for number of units at school? Any ideas? Chat popped up. 12 is a great option, Natalie. 12 is full time. So maybe doing 12 will show it does it by basically full-time semesters. Another good choice is 15. You usually need 60 units to transfer if you want to go on to a 4-year university. And if you want to do it in 2 years, community colleges are often called 2-year colleges. The only way you can get out in 2 years with 60 units is doing 15 a semester. So this would be like the 2-year setup, 2-year plan. So those are good options. So you want to pick the width and bins based on what's a good option for the category you're working on. Shoe size, I probably wouldn't want anything bigger than a 1. So graph, histogram, shoe size, what does it do automatically? It does it by 1. That's good. Okay. Let me bring that table back, or the ages back up. Another way you can see stuff that looks like this, we could do stats, tables, frequency. So I'll write this down in a second, but I want to show you how it looks compared to this. And I can do bin, so I'll set up the bin like it has. So doing a table also will give you the values, and it might be easier to read. And we can have both frequency and relative frequency on there. And it shows both. So let's see, how can I keep that on the screen a little bit and still write? There we go. So another option that's good for histograms. Did I have the option to choose? Oops, cancel. Didn't want to save. It also does any question. So this is like the bar graph. I can choose any category, including gender. So another good option that isn't graphical is I'll show it again here. You go stats, tables, frequency. This is probably the better one to use on homework unless it shows a graph and you need a picture of the graph. Okay. I do want to talk about a little bit more stuff of the information here. So right now I've got it set up with 10 to 15, 15 to 20, 20 to 25, and it goes all the way down to, it doesn't show the 70 to 75, 70 to 75, does it? It goes 65 to 70 and 75 to 80. What this doesn't show you is holes. This won't show you holes in the table unless you're looking for it. Unless you look closely. So this goes all the way down. I'm going to do the last 3 groups as an illustration since I'm writing out the notes. And notice it's missing 70 to 75. It had a frequency of 0. So it doesn't show it. This table actually it does show something useful. It shows the widths of each graph pretty well. So it doesn't show the holes very well, but the width is easy to calculate. And sometimes the homework asks you the width. Width is easy to calculate. In fact, it's easy on all of them. The way to calculate the width, even on the graphical ones, is that yeah. It's a little harder to see there, though. You subtract consecutive numbers on the left. And what I mean by that, I could do 15 minus 10 equals 5. 20 minus 15 equals 5. 65 minus 60 equals 5. The only part it doesn't show up well is when there's a hole. Here, 75 to 65 doesn't show well. This format will work on the graphs if you've got it listed on the graphs, and you just look at 2 consecutive columns. Even with the holes, you can see it. 65 to 70 there, 70 to 75 here. So both the graph and the bar plot, you can find the width easily, but it doesn't work well on StatCrunch or on the homework. A little more information for you, and then we'll do one of the homework problems. These numbers on the left-hand numbers, those are called the lower class limits. And the right-hand numbers are called upper class. Let's see. Do I need to show that? If they ask you for I don't know that they do, but if they ask you for the midpoint of an age range or a range of numbers, particularly in these bins, another word for bins is classes. So we call them bins and classes. I can find the middle age based on adding, add the two consecutive values on the left, which means in order. And divide by 2. So for example, right now I've got 10 to 15, 15 to 20. If I want to find the middle value in this category, I'm going to take the two values on the left and I'm going to divide them by 2. 10 plus 15 is 25. 25 divided by 2 is 12.5. I don't know if they'll ask you that, but I know they used to, and I think it's worth showing you. Is there any questions on this? I'm going to do a homework problem with you and walk you through some of this, or you can see a little bit better. Okay, we'll come back to this. Must have already closed it. So we're going to take a look at homework 2, problem number 9. I'll put this on the left. And it says the data below represents the capita or average disposable income, which is income after taxes, for 25 randomly selected cities in a recent year. Complete parts A and B. A is construct a frequency distribution with the first class having a lower class limit of 30,000 and a class width of 60,000. So what I'm going to do is I'm going to open this in StatCrunch. And let's see if the tables will help me here. I think tables was more useful in seeing some of this data. And I'm going to leave frequency and relative frequency for now. I do have the choice of where to bin. Let's see where it does automatically. Here it did 30,000 to 35,000. It's not a width of 6,000 like the problem asks. Let me click. Nope, that's too big. Maybe make the numbers a little bit bigger. So what I'm going to do is I'm going to do the table and I'm going to tell it how to bin it. I'm going to tell it to bin the numbers and I'm going to do it exactly what it says. 30,000 with a width of 6,000. You have the option of storing it in the data table. I don't need it. I think having it here is useful. So I'm going to put the numbers I see here. The left-hand numbers are always good to go. I told you that it will only go up to one. This doesn't include 36,000. Homework doesn't want me to put 36,000. It wants me to do one less, which would be 35,999. One less than 42,000 is 41,999. Notice I have a gap. 42,000. Next thing is 48,000. So the 48,000 goes here. And one less than 54,000 is 53,999. I need to fill in the missing values here. You can either compute it or if it's helpful for you and you don't want to do it, come over here and set up the graph to have the same information. 30,000, 60,000. I'll click compute. And now when I put my cursor over the box, it tells me it's 42,000 to 48,000. So 42,000 to 48,000. We don't want to put the 48,000. We want to put one less.
Why do we always put one less?
Because that's how the homework wants it. It does not want you to have it. The reason why is if we did 30,000 to 36,000, we don't know exactly where to put 36,000. Does it go in the top row or the second row?
Oh, okay.
Does that make sense? Like 42,000, yes. Do I put it in this row if I did 36,000 to 42,000, or I do it in this missing row on the table or this missing column right here? So by doing it that way, there's no confusion of where the values in between each group go. And now we can pull the frequencies directly from the table. 14, 10. There was none here, so 0 for the next one. And 1. And we'll click check answer. And now it's going to say construct a relative frequency distribution with the first class having a lower class limit of 30,000 and a class width of 60,000. And they're going to make me retype all of these values because the people at StatCrunch suck. Or not StatCrunch, my math lab. This is really annoying when there's like 10 rows and they make you do this a few times and then you miss just one value on one of the things. Means that if you want a perfect score, you got to redo it all. It's very annoying. And now my relative frequencies are over here. You can choose to put a 0 in front if you want. You don't need it. If there is no value there, you do need to put a 0 though. Do not notice I've got 0.4. If I have a space in there, it's going to tell me the answer is wrong. And so if it just told me it's wrong, double check you don't have spaces in there. So if I check answer now, it should be correct. So even a space, like accidentally hitting spacebar, will screw it up. And that's how we do that to have a question. And the biggest confusion is these classes dropping down by 1. So I wanted to show it to you. Any questions? If you guys don't have any questions, that's actually all we're covering today. So if you're in the class that has the Khan Academy, the support course class, the next couple weeks, like on Thursday, we're doing 2.3 and 2.4. It's still on graphing. We still are not doing a lot with math yet. We're doing a lot of copying from StatCrunch and putting it over, and using graphs from StatCrunch. It's a good time to try to get as many of the Khan Academy assignments out of the way as you can. If you're not in the stats course where it has a support course, you don't have to worry about it. Just try to stay on top of these things. Stay on top of the homework. I'm not worried so much about the people that attend these synchronous Zoom sessions, because usually you guys really want to learn this stuff and often work ahead. I know Caprice is working ahead. I believe Natalie was working ahead. I know Natalie was working ahead. I think I helped her. So stay on target. Keep it up. Keep up the good work.
Do you think you could go back to the pages of notes?
Yeah. So do you want this page or a previous page?
The one where it said left hand numbers and then right hand numbers. Okay.
When you have time, if you could help me go over question 10 from the homework. I got a little stuck on that one and I was trying to do it.
Yeah, let's take a look at it together. Where'd you go? I'm going to close that because I don't need that data set anymore. I had the homework open here, so I'm going to click on next question, number 10. So it says the data to the right represents the top speed in kilometers per hour of all the players except goaltenders in a certain soccer league. Construct a relative frequency distribution, a frequency histogram, and a relative frequency histogram. What percentage of players had a top speed between 26 and 29.9 kilometers an hour? What percentage of players had a top speed less than 13.9 kilometers per hour? So this looks like it's going to be one of the pain in the butt problems. Oh, good. They already give us the left-hand columns, though. That's good. So what we're going to do, notice the data is summarized. It doesn't have 4 people's scores for the 10 to 13.99. I don't know if all 4 players had a speed like 10 to 11 or if they were all close to 13, so I don't really know. So let's see what we can do in StatCrunch and go through this problem. And I'm betting this is one of those problems where midpoint was an issue. So let's see. It wants relative frequency. I'm going to do stats, tables, frequency. No, I don't want to do that. I want to do graph. It's still doing it. Okay. Let's see. Can I do this in StatCrunch? This might be one we have to do by hand. No, these are data values. Let's just calculate the frequency based on that. Let's see what we can do it as. See if this helps. Number of players. Nope. So let's do stats.
On my end, it's allowing me to select either speed or number of players. I'm not sure if that has anything to do with it.
For which part here?
So when I go to data, stat tables and frequency, when it selects columns, it's allowing me to either select, or were you on graphs right now?
Yeah, I've got it up here. There's the number of players. I think it's going to cause a problem now. Notice it says all the same relative frequency.
Yeah.
That's not good. They don't have the same frequency. So what we got to do to address this is we got to do this one kind of by hand. So let me show you how to do it. So I'm going to make a list of the numbers. This is number 10. And my number of players is this. Should be different than yours, but for explanation's sake, I'm going to use the ones I've got. To find relative frequency, we need, remember when we were talking about frequency last week, it's the total in each group over the total number in general. So I need to know what the total number of people is here. So let me get out my handy dandy calculator. Where are you? There we go. I have a little more room here.
You said frequency was the total in each group divided by the total of what?
Total and all of them. Okay. So what I'm going to do is I'm going to add up all these numbers. I'm going to show you. So we're going to add up all the numbers. Oops. 19 plus 68 plus 333 plus 187. So I'm getting 618. What I'm going to do is take each of these values and divide it by 618. So 4 divided by 618 equals. And I'm going to write down as many decimal places as I can now, and then look what it wants me to do later. So I did the first one, then I can do 7 divided by 618. And then I'll do 19. You got to do this for each of them. You don't need to write 19 divided by 618 like I'm doing. This is for teaching purposes. But I do recommend writing down all the numbers if you got the time, or at least more than they asked for. They say round to 4 decimal places. You should write down 5 or 6. That way, if something's wrong, it's easier to go back and find out what you did wrong. 68 divided by 618. 1100323362. 333 is above half. Yep. And finally, 187. Okay, I've gone through, I've done this. Now I'm going to go back to the problem and look what it's asking in particular. So it says put in the relative frequencies to 4 decimal places. So I'm going to do 4 decimal places and look one to the right. And if this number is 5 or larger, I'm going to round up. In this case, it is larger, so I need to elevate the 4 to a 5. This is going to be 0.0065. I do this one here, 4 decimal places. The 2 is less than a 5. I don't round it. So I'm going to do this on all of them and just write down what I need. Because if I make a mistake, I want to go back and find out if I did a typo first rather than recalculating everything. And this one has a round up here also. So 8 says make the 5 go up to a 6. So that's what I'm going to put here for the relative frequencies. 0.0065. Tab gets you through them or between the boxes easier. I like using tab. Okay, let's take a look if that was good. If not, I got to go back and check what. Okay, good. I did it right the first time. If you do this where you write down all your work, let's say I did one of them wrong. I can go back and check which number, see if I did a typo. Check these numbers first, make sure there's no typo. If there's no typo, then come over and check my rounding, make sure I didn't round anything wrong. And then if I don't have anything rounded wrong, then I can recheck my arithmetic. Doing the calculator took the longest. So having the values written down, I can quickly check for errors. So now it wants a frequency histogram. Let's see if we can do that, or we just have to look at the pictures. It's doing 10 and 14, 18. It looks like the widths are 22. I don't know that any of these graphs, the bar plot. Oh! Bar plot with summary should help. I'm going to do categories are in speed and counts are in number of players. So it's going to look like a bar graph. The bars won't touch, but it does give them to me. So I just need to find the graph that matches that. It's got low values, then comes up the second column is the highest, and then the right column dips back down. It looks like A is the only one that looks like that. Relative frequency, I'm going to do this as a new graph just to illustrate to you what's going on. We're going to do graph, bar plot with summary. I'll set it up the exact same way. And we're going to say relative frequency. Click compute. And look at those graphs. They're identical, aren't they? The shape, the columns. So your relative frequency graph looks identical to your frequency graph. The only difference is look at these numbers on the left. Frequency goes from 0 up to 350 basically. And relative frequency goes up to 0 to like 0.6 or so. Relative frequency never goes higher than 1. But the graphs look identical. So the percentage of players between 26 and 29.99, I'm going to use what I got on my document camera here for this one. So it asks for 26 to 29.99. This is the second to last row, the 333 row. So I'm looking at this number right here, 26 and 29.99. As a percentage, I had 0.5388. To make it a percentage, you move the decimal point right twice and add a percentage sign. 53.88%. Don't round to 2 decimal places first. Do the percentage, make it a percentage first, then you'll have 2 decimal places there. So I should have 53.88. The percentage of players that had a top speed less than 13.99 was this top column. So I'm going to show you do not do this. I'm going to show you what happens if you round first. 10 to 13.99. I had 4 players. The value was 0.0065. So this is bad. Bad. Don't round. I mean, the number itself isn't bad. Bad is rounding first. If I rounded 2 decimal places first, this would go to 0.01. And then as a percentage, this would be 1%. Notice what happens if I do that. No. So don't do that. Do it the right way. Right way is percentage first, then round. So if I move the decimal right twice now, I get 0.65%. And now it's already to 2 decimal places and I don't need to round. So this should say 0.65%. And that's it for that question. The hard part was figuring out what to do here, right? It's not something you could do in StatCrunch. We had to do this by hand. I'm sure there is a way to do it in StatCrunch, but I think it takes longer to do it in StatCrunch than just pulling out a calculator. Any other questions?
I think that was it for me. Thank you.
All right. If you got no further questions, you are free to go. I will see you on Thursday.
Thank you.
Have a good night.
Recording stopped.